unlikely event that those balustrades became live, okay, and you were touching it at the same time, that would be a significant risk if the balustrades were not bonded to earth. Now, our balustrades, we have connected them to the rebars within the structure, okay, and the rebar in the structure is connected to earth. So it's all at the same potential and it's all safe. Guys, welcome to Asher and Gad channel. Once again, making Africa home again, one family at a time. Today, I bring to you a brief video mainly on earthing, okay, the importance of earthing in the electrical installation, earthing, bonding, and also a quick tip on the lightning protection system, which I've covered previously. Okay, so let's get straight into it. What is earthing to start off with? Now, earthing in an electrical installation is really provided for your safety, okay? Earth cables, you tend to see them as they are green and yellow cables, okay? And those cables are provided for human and animal safety. What do I mean? Now, if a piece of electrical equipment becomes faulty and you happen to be touching it, if there is no earthing system, then the faulty current will pass through your body as it's making its way to the source. And as it passes through your body, guess what's happening? You are getting an electric shock. And if you don't understand how that works, please click up here to watch our video on the principles of the electric fence system. I explained in there how how you get electric shock, etc. And that is the same principle, really. So you need an earthing system. Is a system of, if you like, low resistance cables that allow any faulty electric current, let's say, to flow to the earth, okay, to flow to the earth, okay, or to flow back to the source of power rather than flowing through your body. That is the earthing system. So the earthing system is provided for human safety to prevent you from having an electric shock, okay? And also, as the earthing system, as if you have a faulty current flowing through these earthing conductors, the circuit breakers will also trip and, if you like, disconnect the source of power, okay? So the circuit breakers themselves need to have that earth connection, because if there's a faulty current going through earth, then it's not going where it's normally supposed to go. Because normally, again, the electric fence video I referenced will help you understand, normally current flows through the phase conductor and then back down the neutral conductor. It flows that way. So if a piece of equipment is faulty, the current that's flowing to the equipment is coming back. It's not fully coming back. Some of it is going to earth. That's how the circuit breaker detects that there's a problem, a fault, and disconnects the circuit. Okay? Without the earth, it wouldn't be able to do that. So, earthing is for our safety, and this is very, very, very important. So we have to make sure we get it right, okay? I remember when we were buying electrical equipment from a place in Accra, the guy was joking, oh, we get shocked all the time in Ghana, so we're not worried about that. But it's, that's obviously a very flippant statement, but we need to take it seriously and do it properly, okay? Now, so that's earthing, or grounding as the Americans will call it. There's also something called bonding, okay? Now, what is bonding? Some references will call it equipotential bonding. Now, bonding is where you have various different metallic elements. In the electrical industry, we call them extraneous metallic elements. And an extraneous metallic element is just a piece of metal or metallic equipment which hasn't got any electricity connected to it, okay? But obviously metal conducts electricity, so it can become live, okay? So if you have two pieces of extraneous equipment, metallic equipment, which can become live, if you happen as a human being to be touching them both at the same time, if those two pieces of equipment are not at the same potential, then any faulty current will pass through your body, i.e. you get an electric shock, and you don't want that. So bonding means those two pieces of metallic equipment will have a connection to the same earth, therefore they'll be at the same potential. So in the unlikely event that you happen to be touching a metallic balustrade and let's say the structure of the building at the same time, because the structure of the building and the metallic balustrade are all connected to the same earth, they are at the same potential, therefore the faulty current cannot pass through your body, and therefore you'll be safe. I hope that makes sense. Okay, so we have to connect all those items of equipment to earth. For example, coming back to the balustrade, if you remember how the back of our building looks, you can see the picture on your screen. Yeah, we've got metallic balustrades which are not too far away from the electric cable, as it happens. So, if in the unlikely event that those balustrades became live, okay, and you were touching it at the same time, that would be a significant risk if the balustrades were not bonded to earth. Now, our balustrades, we have connected them to the rebars within the structure, okay, and the rebar in the structure is connected to earth. So it's all at the same potential and it's all safe. The building itself needs to be what we call an equipotential zone. Everything metallic in the building must be connected to, if you like, the same earth reference and therefore be at the same potential in order to be safe. Now, obviously, the likelihood of you touching the balustrade and structure at the same time as, there being a lightning strike or some sort of faulty electrical scenario is obviously is rare, but still electrical systems design cater for the worst case scenario in order for you to be safe. Now, there's another reason why we bond, and I'm sure you've all experienced this before, where sometimes you touch something by accident and you get a little bit of a shock, not a harsh shock, but just a little bit of an electrostatic charge. It could be a handrail, it could be anything really. You just get a little shock. When that happens, what it means is that item of metal is not correctly bonded to earth, and that is how you solve such problems. If you find yourself touching a piece of item in your home and you're always getting a funny sort of kick to it, even though that item is not something that normally conducts electricity, it means that metallic item is not properly bonded to earth. So get your electrician down to inspect it and get it bonded to earth to prevent those types of uncomfortable electrostatic charges to your body. Oh, okay. Now, types of earthing in the electrical system overall. We've got different types of earthing that comes when you're installing your power into your home. There are various types. I won't go into too much detail because it's quite technical. However, there is a link to an ebook in the description which goes into more details and tells you all you need to know, all you need to consider from as usual in a high level perspective, so that you know what to do when you're building your house. Okay, so earthing systems, there are systems that are called TT, TNS, TNCS, IT. Won't bother going into the details of what those mean, but all you need to know is in Ghana, domestically, the Ghana system is a TT system, okay? All that means is that for each home in Ghana, you will have your own dedicated earth electrode. You must have your own dedicated earth electrode in your home for the ECG supply that comes in, okay, which is very, very, very important. So just make sure you have an earth rod. Typically it will be a 6-foot earth rod which is rammed into the ground, or it could be, again, depending on the nature of your soil, it could be an earth mat, or it could be a whole array of copper in your ground in order to get you the right level of resistance. Now, which brings me nicely into the soil resistivity. When it comes to earthing, or when it comes to building design and engineering, it's not one solution fits all, okay? What you need to do really where you are building is to understand the nature of your soil and the resistivity of your soil. Remember, again, if you go back to the electrical fence video, if there's anything faulty in your electrical system, you want that faulty current to go straight to earth, okay? And the only way to go straight to earth is if the resistance is low, the cable's resistance is low, and if the soil resistance is low. If you happen to test your soil, which you have to do in the beginning, and the resistance of the soil is too high, all that means is that you have to invest more in your earthing installation within the ground, which essentially means you have to put, in simple terms, you have to put more copper in the ground, connect more copper together in the ground, copper mat, whatever. You pick some pictures on your screen, which will give you a lower enough resistance so that your system is safe. Okay, that's what it means. And there are various ways of doing this, various means of testing your soil, and I cover that in the ebook in the description link. So please do that. Do not do, if you like, one system covers all, because you don't want to build the whole building, just put a single rod in the ground, only to find out later on that your earthing system is inadequate. It won't be the end of the world. As long as you've got enough space, you can still supplement, but it's best to do it in the early stages. Now, there are various sources of power that will be in your home, okay? Various metallic elements. You for those of you who have a generator, that's a source of power. You know, it has to have its own earth connection, okay? ECG mains coming in has to have its own earth. That's a TT system I talked about, the own rod in the ground. You know, you have to bond all the metallic parts in your structure, the rebar, metallic balustrades, if you have them. And even the lightning protection system also has to be bonded to earth, okay? So if you're going to have a standby generator, make sure that has its own independent earth rod next to it, all right? Which is, again, very important, okay? ECG, I already talked about. You already have your independent earth rod, metallic bond, extraneous metalwork to earth, okay? Now, lightning protection. If you haven't watched the video on lightning protection, please click up here to watch it as a recap. But in that video, I talked about down conductors, okay? The down conductors conduct the electric charge from the sky, okay, down into the ground. When it gets into the ground, there's an earth termination network, which is, again, you just earth rods, if you like, that direct that high voltage current in nicely, safely into the ground. Now, if you coordinate things properly, when you're initially building the structure, you can connect to the top of the iron rods or the rebars, which are in the columns of your building. You can connect to the top because they are vertically continuous all the way down. You can connect to the top and then connect at the bottom to the earth rod in the ground. And so that, therefore, the rebar in the structure forms your down conductor. Okay, and that is good planning, and obviously that makes your building more visually appealing. If you don't do that, no worries, and then you'd have to run a tape on the outside of your building, as we talked about in the other video. Run a tape on the outside of your building down to the earth termination. In that scenario, all you have to do is paint the tape the same color as your building, and you barely notice it. Okay, but if you can do it in the beginning, tie it to the structural rebar, then that is absolutely perfect. Okay, now we talked about bonding. Imagine if you're on the roof and you happen to be having your hand on the structure. You're in contact with a piece of metal on the roof as well as the structure. Okay, the structure rebars themselves need to be connected to earth. The piece of metal that you may be touching on the roof also needs to be connected to earth, so that everything is at the same potential. If not, if you happen to be touching both at the same time and they're not at the same potential, and there is a faulty electrical incident, then that's where you can have current coming through your body and have an electric shock. You see, there's a saying: the more you teach, the more you learn. The more you learn, the more you teach. Even as I'm saying this to you guys, I know that I'm reminding myself, and I need to check a couple of things on my own building. So it's always good to share knowledge around. You help others and you help yourself. Okay, so once you have all your earthing system installed, you tested your soil resistivity, you know exactly the plan that you're going to undertake for your earthing, your generator, your lightning protection. When all that is in place, the final thing you need to do before you can certify that you have a compliant earthing system, and a compliant earthing system is one that has a low resistance, because remember, you want the faulty current to flow to earth and not through your body, or not through the body of an animal. Okay, so there is a test, and that is called the resistance to earth test. Okay, you have to get your electrician who has the right machinery, the right test machinery, and that is an issue I found in Ghana. You know, many electricians I interviewed didn't have the machine. Probably, I think out of the 16 I interviewed, only 2 out of 16 had it. But you need to enforce, if they don't have it, they can go and hire it. They need to test the earth resistance to earth. Absolutely important. Test the resistance to earth before you can sign off your electrical installation as safe. Ideally, when you test the earth resistance, it should be less than 1 ohm. That's really perfect. And when you're testing, the electrician should try to test on a dry day. Why am I saying that? The dry day is the worst case day. If you test the earth resistance on a dry day and you get a very low resistance value, less than 1, okay, then happy days, everything is working. Because on a wet day, it's even better, because water, wet surfaces, wet ground, it has the lowest resistance, low resistance, because water conducts electricity very well, so no issues there. So if you test on a dry day and you have a compliant result, then you know that you're going to be fine on any other day. So please test on a dry day. In terms of the method of testing and the machine that is used and how the electrician actually conducts the test, I won't bore you with those details, but if you refer to the ebook and the link, it will give you those details. So again, remember, the purpose of this particular channel is to help everyone who's building, not necessarily engineers. So you want to be able to observe the artisan, know generally from a high level point of view what they're doing, and when you look at what they're doing, you will have comfort that they're doing the right thing. Whether it is you managing it or it's your project manager managing the process. The guy will come in with his machine and he'll put the cables in certain positions, and you just have confidence that yes, this person is doing what I expect them to do. Okay. Now, obviously, as with all systems, it comes with a cost. Not too significant cost. Obviously, you've got cost of the electrical rods. Some are 6 foot, some are 4 foot. The copper mat, and the extent of expenditure in your earthing system will all depend on your soil resistivity test that you hopefully do upfront. Okay. I've put more cost details of some of the earthing system components also within the ebook below for those who are interested. All right, so that was just a quick recap of the lightning protection, but most importantly, talking really about earthing and the safety of it. Okay, the electrical systems must be earth. The building itself must be, if you like, an equipotential zone, as in everything metallic within the building, whether it's a piece of metal that has electrical wires in it, or whether it's just a piece of metal on its own, like a balustrade or whatever it is, the structure itself, everything in the zone of the building. Okay, if I was to put a cone over my building, everything within the cove, the cove, if you like, or the zone of the building must be at the same potential, so that it is electrically safe. And if there are any faults, be it on an electrical item or a metallic item, that faulty current does not pass through your body, but goes safely to the ground, because the ground is a much lower resistance than your body. Okay, well, I hope that was useful. Don't forget also to install your RCBOs in a distribution board. Okay, and I've talked about that in many videos. Click up here if you haven't heard about the RCBOs and watch the video about the distribution board. And yeah, have a look at the ebook for more details for those who are building and are interested in that. Guys, well, I hope you enjoyed this session. Hope it wasn't too technical. Try not to make it too technical, just to give you an overview and a high level understanding. So from God, it's Kemis here. From me, it's guys, Yebishia. See you next time.